In this video, we're going to begin section 3.5 on inverses. So our goals for this section are to define what an inverse function is and how we can recognize when a function has an inverse. Then we'll talk about how you can test if two given functions are actually inverses of one another. And then finally, how do you find the inverse function and sketch its graph? Okay. All right, so let's begin with an intro to what is an inverse function. So remember that a function has an input x and it's got an output y. So what I want now is I want something called an inverse function. So the inverse function, the way I'll write it is I'll write f, and then in the exponent I'm going to put a -1. That's not actually an exponent, it's just notation that means an inverse. Okay, and what the inverse function is going to do is it's going to have an input y and output x. So in other words, it's going to switch the input and the output values in the original function. Okay, so let's take a look at an example. All right, so in this first function, it says f of x equals x cubed. Okay, so let's graph this thing. In fact, let's take a quick pause. Let's do a quick 30-second pause. See if you can draw in this graph. In fact, see if you can draw in both of these graphs in those 30 seconds. 3, 2, 1, pause it. Pause it and see if you can draw those two graphs. All right, so hopefully you did that. Hopefully you paused it and tried drawing these two graphs. So at this point, over the last few sections, now we've seen these ones a bunch. So hopefully we're getting more comfortable with drawing these graphs. So x cubed, that's the graph that sort of snakes upwards like this. It gets momentarily flat at the origin and then it keeps going up. And then our x squared, our parabola, our upward facing parabola, got this vertex at the origin. Okay, so that is doing this. Okay, all right, so in that first function, in my x cubed function, what happens if I plug 2 into it? So f of 2, if I plug 2 into this as the x value, well, 2 cubed is 8. So f of 2 equals 8. Okay, so based on what we want the inverse function to do, that means f inverse should switch the input and the output. So 8 should be the input and 2 should be the output. They need to get swapped. Well, what happens with the g of x? So with g of x, if I try plugging in 2, if I plug 2 in, 2 squared is 4. So g of 2 equals 4. But I also notice that if I plug in -2, I get the same output. Like -2, when I square that number, I get 4. So g of -2 equals 4 and g of 2 equals 4. So, well, what would the inverse be here, the value of the inverse? So if I tried to ask myself, okay, what is g inverse of, now I'm switching the input and the output, so now I'll be inputting 4. Well, I cannot say that this is going to be equal to both of those values. I cannot say that it's both 2 and -2. And the reason for that is, well, I want this inverse to be a function. And a function can't have two outputs like this. Okay, so if I allowed something like this, a picture like this, there would be a problem when I go to define the inverse. I'll end up with an input like 4 having multiple outputs, but that's bad, and it won't be a function. Okay, so here is the key fact. For a function to have an inverse, it must pass the horizontal line test. And what that says is that any horizontal line has to cross the graph at most once. Any horizontal line has to cross the graph at most one time. So will the two functions that we just drew above, do they pass the horizontal line test or no? Okay, so let me just recopy the graphs. So our x cubed function, this one snakes up. That's kind of flat at the origin, keeps going up. And then our y equals x squared parabola, like this. It's got the vertex at the origin. Okay, so let's look at these two graphs. So in this first picture, x cubed, I'm going to draw a few horizontal lines and see if they check out. Okay, so I'm going to draw first this line, horizontal line. So is that okay? Well, it crosses the graph one time, but that's okay. The horizontal line test says, well, at most once is good. So one time is just fine. What about if I draw this horizontal line? That's also okay. I just crossed it one time. So this one was okay. This one was okay. And it's not hard to see that if I drew any horizontal line, it would cross this thing just one time. So that's going to be fine. So as a result, this function, its graph, passes the horizontal line test. What about our x squared, our parabola? So let me draw some horizontal lines. Okay, so first, what if I draw this line, this horizontal line? So that crossed the graph 0 times. But 0 times is okay. It just says at most once. So 0 is fine. Crossing it 0 times is okay. That's okay. Let me draw another line. What about this horizontal line? So this one crosses it twice. It crosses it once here and once there. So this one is not okay. This one's not okay. I'll put a sad face. So if I have any horizontal line, even one horizontal line that crosses it more than one time, then that graph fails the horizontal line test. If it fails the horizontal line test, the function's not going to have an inverse. Because I'll run into this problem that I saw here, where I could have these 2 points, these 2 problematic points, so that when I go to define the inverse, when I plug in that output, when I plug in that value into the function, I'll be getting more than one output, and I don't want that. Okay. All right, so we are going to flip that page. We are going to flip the page. All right, so I want to note something. When a function like this, x squared, even when it doesn't pass the horizontal line test, sometimes I can do something to it to make it have an inverse. I can sometimes accomplish that by restricting the domain. That means making the domain smaller than it is. So I'm going to define a new function, h of x, and I'll let h of x be x squared, my parabola. But instead of letting my domain be everything, I'm just going to look at part of the parabola. So if I let x be greater than or equal to 0, and then I draw this thing, so I'll draw some axes. Now I'm just looking at the part of the parabola where x is greater than or equal to 0. So that is only going to be the right half of the parabola, just the right half. Okay, and if I just look at that part of it, well, now it passes the horizontal line test. Now it passes the horizontal line test. Okay, and if it passes the horizontal line test, this thing will now have an inverse. This thing now has an inverse. Okay. All right, so the key fact there is, if a function f passes the horizontal line test, then it's going to have an inverse, so I can define it. Okay, so the way I define it is I can say that when I write something like f inverse of b equals a, well, that means that's the same thing as saying that in terms of the original function, the input and the output are what are getting swapped. So a is getting plugged in the original function, and b is what we're getting out. So anytime I write this with the inverse function, it means the same thing as this in the original function, swapping the input and the output. Okay, so I'm going to highlight these. So these are equivalent to one another.